The broadcast is now starting. All attendees are in listen-only mode.
Hello. Good afternoon, everyone. I'm Salome Girma with the U.S. Department of Energy. I'd like to welcome you to the March edition of the Better Buildings webinar series. Thank you all for taking your time to join us for this session, and I hope it's an educational one to all of you. Today we have put together a list of wonderful panelists who we hope will give you a comprehensive view of the commercial zero energy buildings in the U.S., but also we get to hear from those that are actually creating the policies and building zero energy buildings. We will hear first from Riley Loveland, who will describe the overview of zero energy buildings in the U.S. And New Buildings Institute, or NBI, has done a great work in gathering this data, and she'll be sharing this information with us. Following Riley, I will present on the work of the Department of Energy, the work of what Department of Energy has done so far in the two new accelerator programs we launched focused on zero energy K-12 schools and districts. Next, we will hear from Nate Kinsey from San Francisco Unified School District. He will walk us through the district's zero energy goals and their plans on achieving these goals. Finally, we will hear from Jason Robbins to share the success of Walgreens zero energy building from an engineering point of view. So let me introduce our presenters, and I'll start with me. Again, like I said earlier, my name is Salome Girma, and I lead the commercial zero energy buildings effort here at the Building Technologies Office in the Department of Energy. In my role, I convene key stakeholders, including state and local representatives, legislators, national laboratories, engineering communities, and others to develop a robust adoption of zero energy buildings, but also to generate the necessary program framework to support the investment in cost-effective zero energy buildings. I received my bachelor's degree in mechanical engineering from Stony Brook University and my master's from George Washington University in engineering management. I am also a certified energy manager. Next, we have Riley Loveland from NBI. Riley supports the project management team on various projects, including the Prop 39 Zero Net Energy School retrofit work in California, as well as other K-12 related work. She has a Bachelor's of Science degree in Geophysics, Environmental Science, and Resource Management from the University of Washington, and holds a certifications license in real estate, ArcGIS lead, and is a green classroom professional. Next, we have Nate Kinsey, who is a San Francisco Unified School District's energy manager, where he works achieving the district's sustainability and zero net energy goals through energy efficiency capital projects, improved utility data analysis, and behavioral change programs. He has a bachelor's and a master's in environmental studies from USC and swore he would never work in a school district like the rest of his family. I guess that plan did not work out, Nate. Finally, we have Jason Robbins, who is currently the manager of global building systems for McDonald's. Before joining McDonald's in 2016, Jason led the engineering design team for the state-of-the-art building systems at the Walgreens Net Zero project in Evanston. He's a registered professional engineer and holds a Bachelor of Science degree in mechanical engineering from Milwaukee School of Engineering. Thank you all for being with us today. And little housekeeping items for everyone. Before we get started with our presentations, I want to remind our audience that we will be on hold for questions until near the end of the hour. Please send in your questions through the chat box on your webinar screen throughout the session today, and we'll try to get to as many of them as we can. This session will be archived and posted to the web for your reference. So Riley, over to you.
Hi, my name is Riley Loveland, and I'm with the New Buildings Institute. Thank you so much for attending this webinar today. I'm really excited to be speaking. If you want to go to the next slide, that would be great. And you could even go one more. So the New Buildings Institute is a national nonprofit working to improve buildings for people and the environment via innovation and leadership in technology, policy, programs, and design. If you wouldn't mind going to the next slide. NBI researches and defines leading-edge practices and technology applications for high-performance buildings and translates them into innovative and practical solutions for the utility, energy efficiency, and commercial building industries. If you wouldn't mind going to the next slide. So why should you go ZNE? ZNE is the next step in sustainable high-performance buildings. With codes and standards continuing to ramp up, ZNE is a way to innovate now to save money in the long run. ZNE buildings contribute to stronger, resilient communities. Learning, working, and living environments are more comfortable and productive due to connectivity to nature and passive design strategies. These buildings are high-performing with low operating needs and operating costs, lower net energy costs, and higher asset value. ZNE targets can also be specified early in the design process via RFPs and other design requirements to make it an easier way to accomplish ZNE. Next slide. So one way that we are tracking the success of ZNE is through our Getting to Zero database. NBI works to identify, research, analyze, and promote commercial buildings that are leaders in low and zero energy performance outcomes. And as such, we maintain the most comprehensive database of zero net energy verified, emerging, and ultra-low buildings in North America. And I'll define those in just a little bit. You're able to search our database by location, building type, ZNE status, and energy performance metrics, as you can see on the left side of the slide. We're always looking for more ZNE projects, so if you have a project to submit, if you've looked through our database, or just one off the top of your head, please do so through our online registry, or you can also email info@newbuildings.org. And this page, our Getting to Zero page, is also where you can find answers to any questions you may have about the tracker or database. Next slide, please. You may be able to tell through this webinar topic that ZNE is gaining momentum. Via our Getting to Zero database, we've been able to track the progress of ZNE buildings. So for some background really quickly, the three types of ZNE buildings are ZNE Verified, which is a building that has 12 months of meter data that shows zero net or positive energy production over those 12 consecutive months. ZNE Emerging, which is a building that has publicly stated a goal of ZNE, but has not yet demonstrated that they've achieved that goal. This building may be in the planning or design phase, currently under construction, in operation less than 12 months, or has not yet quite documented the ZNE performance over 12 consecutive months. And lastly, ultra-low energy is a building that has demonstrated significant energy reduction and technical progress towards goals of energy reduction, even though they may not have pursued ZNE originally or on-site renewables. Next slide. ZNE buildings have seen dramatic growth in the last decade, and especially in the last year. In 2015, we listed 191 ZNE verified and emerging projects, whereas this year on our Getting to Zero list, we listed 332. That's an increase of 74% in a single year. Next slide. ZNE projects are located in over 40 states and provinces in North America. Next slide. ZNE buildings are feasible and currently exist in every climate zone in the United States. As you can see by the pie chart on the right, certain climate zones do dominate. However, every climate zone across the United States is touched by a ZNE building. Next slide. ZNE and ultra-low buildings are possible across many building types, and some examples of these building types are here. These buildings include, on the top row from left to right, the IDEA Z2 design facility in San Jose, California, the Richardsville Elementary School in Bowling Green, Kentucky, the NREL Research Support Facility in Denver, Colorado, and then on the bottom from left to right, the Aldo Leopold Legacy Center in Baraboo, Wisconsin, the Center for Interactive Research on Sustainability at the University of British Columbia in Vancouver, Canada, and the San Francisco Public Utilities Commission headquarters in San Francisco. Next slide, please. Who and what building types are aiming for ZNE? Across the building ownership and building type spectrum, public buildings seem to be leading, particularly educational buildings are leading the way to ZNE. Next slide. As centers for change and leadership, the educational sector, particularly K-12 schools, are leading the market towards ZNE. You can see this reflected in all three of these pie charts. Next slide, please. So why schools? Why not? They are an ideal building type with low occupancy. They have sufficient land and they're owner occupied. Going ZNE is fiscally responsible with taxpayer dollars, and it puts more money back into the schools because of lower building operation costs and reduced need for energy. ZNE schools have increased student performance with better occupant health, attendance, and improved teacher satisfaction and retention. They're more resilient to severe weather events and can create safe havens for the community. And as ZNE is not just about design but about operation, schools are the ultimate early adopters and set the example for future generations as operators of ZNE buildings. Schools house the next generation of environmental leaders, so going ZNE can provide hands-on project-based learning opportunities for continued student growth. Next slide. ZNE schools are growing at a rapid pace. Since 2015, the number of ZNE verified, emerging, and ultra-low schools has grown by almost 40%, with California, Kentucky, North Carolina, Texas, and South Carolina leading the way to ZNE schools. Next slide. The buildings or schools that are successfully designed and operated to ZNE can be roughly a 75% reduction in EUI compared to CBEX. This offers a significant reduction in energy use and a significant savings potential. Next slide. And because of these high-performing efficiency strategies, the average ZNE building has an EUI of 22 before renewables. That is across the ZNE verified, emerging, and ultra-low energy buildings spectrum. Next slide. Building cost varies based on location, building type, commodity cost, and the labor market. But the key takeaway here is that the costs are driven by many factors, including the growth of the ZNE market. ZNE buildings do incur an extra cost for renewables. However, our research suggests that ZNE can be delivered for around a 0 to 10% increased incremental cost. Next slide. Some common technologies to approach ZNE include plug load reductions, passive strategies like daylighting, building orientation and natural ventilation, renewables like solar or geothermal, amongst many others shown here. I'll just wait on this slide for a moment so you can read through it. Next slide. ZNE is tough to get to. However, there are many resources out there and available through NBI and many others. Next slide. These resources out there are here to help you in whatever part of the ZNE process you may be in. Whether you're just starting and formulating your initial plans, have some ideas, have approached your district or your building owner, operator, or have finished design and construction and need to move on to the operations portion. I mentioned our Getting to Zero list when I was talking about the database. NBI publishes a list every year of all zero net energy buildings. Again, if you have a project to share, please either submit through our online registry or by emailing info@newbuildings.org. Next slide. There are also many existing case studies that show the feasibility of ZNE, and the key content in these case studies provided here. Some are from NBI, some are from others, that these provide project overviews, energy efficiency features, project planning and design approach, and any lessons learned. These are really valuable tools. Next slide. NBI has also published a communications toolkit for engaging key stakeholders and to communicate effectively the reasons for going to ZNE. This originally was developed for the state of California but provides excellent resources for anyone across the nation or even in other countries looking to go ZNE. The toolkit includes a messaging platform for consistent communication around ZNE, an intro to ZNE presentation that you can use to take to whatever stakeholder you're trying to communicate with, fact sheets, case studies, our ZNE Action Bulletin, which is a quarterly newsletter, amongst many other pieces of information. You can pick and pull whatever you need to use to communicate ZNE. Next slide. I mentioned that within the communications toolkit there are fact sheets that NBI has developed that target specific stakeholder or market groups to address questions and any terminology of ZNE for each group. These all can be accessed through the NBI website, or if you want to email me, you're welcome to do that as well. Next slide. We also provide presentation templates. These are primarily commercial and they carry kind of general ZNE messaging and goals. However, they're incredibly helpful to help you engage your audience. You can also find previous agendas and presentations from other NBI workshops and events. Next slide. I mentioned the ZNE Action Bulletin. NBI releases a quarterly newsletter with updates on ZNE, ZNE News, ZNE Innovation, events, and trainings. So you can sign up on the NBI website to receive it in your inbox quarterly. NBI has many, many resources, and others have many resources to effectively communicate, understand, and build and operate ZNE. For more information, visit our website, or like I said, you feel free to email me with any questions. Next slide. And I have one more thing before I pass this off. We will be presenting at the Green Schools National Conference in Atlanta on March 21st and 22nd. And at the conference, we will be hosting with the Department of Energy a series of roundtable discussions to identify what schools need to be successful as they progress towards ZNE. And we want to hear from you. If you'll be at the conference and wish to participate, or if you still would wish to participate but won't be at the conference, please email or call me at the contact information provided. And as an added bonus, we will be raffling off 2 Amazon gift cards per roundtable. You also don't need to attend all 3 roundtables, just pick one. And again, if you won't be at the conference but have something to say, you're welcome to call or email me and we can set up a time to talk. Please consider coming to provide your feedback. We're really excited to listen. Next slide. And that's it. Thank you for me. My email is a little cut off, but it's Riley@NewBuildings, R-E-I-L-L-Y. Thank you so much.
Thank you, Riley. All right, so let's move on to what Department of Energy is working on in the ZE space. Next slide, please. Next slide, please. Next slide, please. Okay. All right, so in terms of zero energy, before I wanted to dig deep into what we're doing, I wanted to give the overview of Department of Energy's bigger goals. So our long-term goal is to reduce U.S. buildings energy unit index, or EUI, by 50%, and then with the short-term goal of 30% by 2030. And our zero energy efforts help us in 3 strategic areas with research and development, marketing, stimulation, and codes and standards. We're working on each of these buckets, and we feel the zero energy fits in each one of them to accelerate the market. Next. So what is the buildings market, commercial market, look like right now? So there are about 5.6 million commercial buildings comprised of about 14 principal building types, and then out of that, 1 million new buildings were constructed between 2000 and 2012. And there's really no slowing down. And then the average size of the building constructed in the 2000s is 17% bigger than new buildings constructed between 1960 and 1999. So what this means is, with more large buildings in the market, the more the demand for energy, which is also making energy efficiency a critical part of the work that we do. Next slide. So once the Department of Energy started looking into the zero energy concept, we found that there was a lot of confusion in the marketplace. And to avoid that confusion, we felt it was our place to come up with a common definition for zero energy buildings. And we published this common definition in September 2015. And we didn't do this alone. We worked with a lot of other market leaders, including ASHRAE, NBI, AIA, NIDS, and the National Renewable Energy Laboratory. Next slide. And I'd like to mention that if you Google common definition for zero energy buildings, you should be able to find this information. If not, the link is there. And again, this presentation is archived, so you'll be able to receive this information with the link. And so what is a zero energy building? So in aspiring to build a zero energy building, you must first focus on energy efficiency. So you have to reduce your energy consumption by 50 to 70% from your code. And we realize the gap between 50 to 70 is vast, but it's also because we're trying to cover the entire country, and we realize different states use different codes. But basically, if you need to first target your energy efficiency, and then so that once you meet the 50 to 70% less code, then you are a zero energy building. And then beyond that, if you are able to supplement the rest of the energy with renewable energy, then you are a zero energy building. So moving forward, please know that we are working on both zero energy ready and zero energy buildings, as we feel that energy efficiency is equally important than just putting a zero energy. Next slide, please. So by definition, a zero energy building is an energy efficient building where on a source energy basis, the actual annual delivered energy is less than or equal to the on-site renewable exported energy. And again, if you look at the scale, if you were to meet just the efficiency piece of it, you are a zero energy ready building. And then when you add the renewable piece, then you become a zero energy building. Next slide, please. So our goal at DOE when it comes to zero energy or zero energy ready buildings is we want to expand the demand, but while expanding the demand, we want to build the framework necessary to get there. So we're working on technical resources such as the case studies for pilot buildings. We're working on design guides, and then we've decided to focus on schools and districts, and I'll go into details about that. But we are also working with other partners from the engineering and architectural community, but also through other programs such as accelerators, to build and move the market. Next slide. Next slide. So we'll start with zero energy accelerators. Our vision, the bigger vision, what we would like to see is we want K-12 schools to provide healthy dynamic learning environments and the resilient community assets that have zero to minimal energy costs. And so through this, what we call the Zero Energy Schools Accelerator program, we launched this program last December. We want to show that zero energy schools are possible within conventional construction budgets, but also we want to help the partners that we have recruited, states and districts, that we want them to establish EUI targets to drive their energy efficiency, then also provide resources to accelerate their zero energy goals and then get them faster than they would if they didn't get our support. Next slide. So Riley just went over this. There's a huge opportunity in working with schools. In short, one school American sets foot each day in a school, and it's a unique opportunity to educate and shape the views of the new generation. But at the same time, outside of salaries, energy costs are the second largest cost to our schools. That's a figure about $6 billion, and some say it's much higher, but that's the figure that we have right now. And in addition, schools are a good replication, they have a good replication potential because they have a very strong stakeholder involvement. And lastly, the zero energy schools are resilient schools which are critical to our community assets, and we know because schools are always a major part of any community, and the resilient community is the preferred community. Next slide, please. And you've seen this slide with NBI. Again, the market, as you can see, the market trends for schools, they are leading the way for more zero energy buildings. Next slide. In our approach in working with schools, one of the first things that we did is it really possible to build zero energy schools from coast to coast within the US? So to do that, we worked with our National Renewable Energy Laboratory, NREL, to conduct a technical feasibility study. And with that, the study focuses on, what are the technologies required to achieve zero energy ready, and then at what, energy units index or EUI targets do schools need to focus on to get to that zero energy goal. And this study was published in November 2016, and the technologies are prioritized across the building subsystem such that design teams can readily integrate the ideas. Next slide, please. To carry out the study, and the NREL team used the listed, what you can see in front of you, the prototype characteristics, which represent the average primary and secondary schools in the U.S. And so you can, I'll give you maybe a few seconds to look at that. Next slide. So basically, some of the best practice technologies are identified here. Classroom orientation on long east-west axis, daylighting in classrooms to avoid additional lighting, demand control ventilation, and energy recovery ventilators using dedicated outside air systems. These are some of the technologies, and again, the list can be found in the detailed technical feasibility study. Next slide. So what does this look like? This is a load distribution for an average primary school, and as you can see, the goal here is to get to below 30 for the EUI. Next slide. To summarize, for all the 15 climate zones within the U.S., basically you need to meet these. What we found is these are the target EUIs to be a zero energy building or zero energy ready building, but it is possible to be zero energy in all climate zones. That's what the study found. Next slide, please. So with this program that we have, the Accelerator, Zero Energy Schools Accelerator, we have recruited about 8 partners. These are 6 school districts and 2 states, and we are also working with a variety of institutions, nonprofit institutions that are already working in this space, and this is the list. We are still recruiting and looking to work for more states and districts, so if you happen to know anyone or you are representative from a school district or state energy office, please reach out to me and we can see what we can do. Next slide. Next, we will talk about zero energy districts. By districts, this is what we mean by is a self-identified geographical area, and our vision for these districts are, communities with energy efficient, resilient, cost-effective buildings and infrastructure that are common throughout the U.S. And with that, our goal is we want to work with these districts in their master planning, but also their financing and ownership structure. And so through that, we are looking to study their case studies, best practices, and pilot examples. And with that, we mean, how do we have EUI targets, other project priorities such as resiliency and economic development, procurement model and design guidelines to ensure efficiency requirements are met by building design teams, integration of energy efficiency, district energy, CHP, and renewable energy systems, and also establishing district energy building system for those districts that are sharing energy among the districts. Next slide, please. We decided to focus on districts because a lot of cities are setting aggressive energy transformation and resiliency goals. But there is no clear pathway to get there, and we feel that districts are one way to get there faster. That's why we chose to focus on districts. Next slide. When we're talking about zero energy districts, we're not just talking about a group of buildings that are, just built around each other, but rather districts that are innovative and that use innovative technologies to meet their energy needs in the most efficient manner. This means, for example, tapping into your industrial sewer waste heat recovery system, or using combined heat and power, or CHP, or solar canopies for electric vehicles charging stations. These are some of the unique innovative technologies that we want to implement for these districts to achieve the zero energy goal. Next slide. So through this, our Zero Energy Districts Accelerator program, we're working with 6 implementing partners, and we're working with 5 other national partners. Next slide. These are the list of all the 6 projects that we are working with. As you can see, it's a diverse group of projects, from low-income housing projects to a redevelopment of an old Ford manufacturing site. And this is also, in terms of ownership, it's a public-private partnership. And we're studying these projects so we can learn from them, learn best practices, but also how can we replicate these kinds of projects throughout the U.S. Next slide, please. So the tallest oak in the forest was once just a tiny nut in the ground. So basically what I'm trying to say is the zero energy concept is still new. And as Riley mentioned earlier, majority of the buildings are starting to be built just in the past year. So we've seen a lot of growth, and the market is transforming, but we have to start from somewhere. So I hope we're all in this on the road to market transformation, where these buildings are a common place rather than a one-off. Thank you. If you have more questions for me that we may not get to, this is my information. Please feel free to contact me.
Great. Well, as Salome just wrapped up for us nicely, ZNE is a very new emerging concept, and we've seen some success over the last 10 years or so. And so SFUSD, with the passage of some local state legislation, really took it upon ourselves to come up with a long-term strategy on how we were going to do this as a district and how we were going to accomplish this as a district for mainly retrofit opportunities. We're in a very dense urban environment here in the city, and we're not going to be building too many new schools. So it was a different challenge for us. Next slide, please. And as part of that process, the ZNE effort really led to a long-term zero carbon goal, and ZNE is at the centerpiece of that, and so that's what we'll be focusing on today. Next slide. So when we presented to our board, we really focused on the 4 topics of the planet needs bold action. As we know, climate change is occurring. It's occurring quickly. And even here in California, with our ambitious greenhouse gas reduction goals, we aren't really doing enough yet to get there quickly enough. So we need to speed that up. There's good examples of jurisdictions all over the world, from California to Europe to Asia, that are really stepping up on the issue of climate, and we want to be a part of it. Other school districts are going ZNE. Boulder Valley has been a big template for us in Colorado on how to think about the process of adopting ZNE goals. And down south in San Diego, they have a ZNE plan as well. So there's other schools working on this. And then we have examples of buildings, as we've seen today, that have gone ZNE and have done it successfully. Next slide. So how are we doing? How have we been doing on the energy side? Next slide. The main way that we go through and do energy efficiency work, like many K-12 school districts across the nation, is through local bond funding and just general modernization. The Sustainability Office was created in 2008, and 2011 was the first real opportunity we had to influence the design and specifications of what our buildings and schools were going to look like. And for the most part, we did a decent job. This is data from 4 modernizations that have recently been completed and had enough data to do a comparison. And you can see the overall EUIs have gone down across the board. Next slide. And we've done really well in natural gas. We're a coastal climate, heating dominant for energy usage. We actually don't have very much air conditioning in the school district at all. And so for the most part, we've done a good job of focusing on natural gas. The Monroe Elementary School example here, we had switched off of and installed, actually gone to electric heating. So that was why that big drop occurred. Next slide. And here we are on electricity. Electricity is a different story. Because our buildings are very old, some of them reaching close to 100-year-old, you're bringing all these new buildings up to code, which means you're adding exhaust fans, you're adding new pumps, you're having new laptop carts, new plug loads. And for the most part, what we've seen across the board is that we can go to a site. Overall, in the EUI, we do a good job. But on the issue of electricity, we really have to focus in on this. Now the big caveat here is these schools were built and constructed right before the LED price curve dropped off the cliff, and so we totally anticipate once we get LEDs into new buildings, we'll see a major reduction. Next slide, please. So what about new schools, new construction? Like I said, for the most part, we're going to be doing modernizations, but in the few cases we do get to do new construction, how are we doing? This is a picture of Willie Brown Middle School. The brand new middle school is being built in the southeast part of the city. Next slide. And we really focused on CHIPS, good design standards, following all the best practices. And for the most part, we are following the same trend here at Willie Brown. Natural gas, the Willie Brown is the blue square, and the gray circle dots are other middle schools throughout the district, doing a good job on the natural gas and the space heating side. Next slide. As you can see, on a square foot basis, very low compared to other middle schools. Next slide. But on electricity, we're right in the middle of the pack. This is a big campus, lots of design challenges during the process. Next slide. And we were seeing that, even designing this building 30% better than code here in California, on the electricity side, we are worse off compared to the rest of the middle schools throughout the district. Now this site does have solar, and once we get the solar turned on and grid connected, we expect to kind of drop down in the middle of the pack. Next slide. But this data that we saw from our 2011 school sites and our new construction here at Willie Brown was really the spark that for us to focus on ZNE. Here's just another picture of Willie Brown. You can see kind of questionable design features of this curtain wall, which is facing south and west. We don't have enough tint on this, so the glare, and so this is the library. The librarian closes all our blinds, which increases electrical lighting usage. It's a great case study on how we can do better, and we've learned a lot of lessons from here. Next slide. So the light bulb moment was actually an MBI event here in Berkeley, just across the bay. We went and took a tour of the ZNE library and heard them talk about how to go ZNE in school districts, why is it important, and what the state has as ambitious goals for accomplishing that. Next slide. There was also the 7x7x7 challenge, which was put on by the California Division of State Architects, which hired 7 firms across the state to do 7 case studies of 7 campuses and all different climate zones throughout California. This is a picture of a high school in Santa Barbara, which is very similar to the type of building that we have here locally in San Francisco. And so we use this as an example of how they could go about it, really brainstormed ideas. Next slide. And we had a kickoff. In December of 2015, we've invited WRNS architects to come present on their ZNE library, which is down about 45 miles south of San Francisco, and to really introduce the idea to the school districts, to all the different departments, facility, bond, maintenance, and anybody else who was interested to know what the Sustainability Office was hoping to accomplish over the next couple of years. Next slide. And then like any good San Francisco or Silicon Valley, we all hopped in our Teslas, just kidding, and did site visits around the Bay Area. This is a ZNE training center in East Bay. As you can tell, they have lots of solar generation and even some wind generation on site. Next slide. Went down to San Jose area and took a tour of a new construction auditorium and small ZNE classroom. Next slide. And went out to the west side of the city and took a tour of this nice building for the City College, which is naturally ventilated. And the purpose of all these site visits was to introduce different departments of the district to ZNE, to show them it was possible, to identify those common threads, to discuss the challenges with the architects and the maintenance teams, and what were their district looking to accomplish. And for the most part, we left all those meetings with positive reviews, new ideas. And so we took all this and helped us with our big master plan. Next slide, please. And so like Salome touched on, all these different definitions of ZNE and zero energy ready and source and site. And so for us, what we've decided is that as a district, we're going to really focus on the site energy as our definition. because it benefits us for a couple different reasons. Next slide. One is we have Hetch Hetchy Dam, which provides us not only with our water, but almost greenhouse-free electricity. And so for a climate standpoint, right, the quickest and most effective goal for us is to get off natural gas entirely. We have this nice backup to do that with. Next slide. And we also, as a school district, said, is natural gas really that transition fuel to the future? Do we have leakage rates in here in California within our local IOU territory that justify the benefits that come with that? And so that's a big topic we really discussed with our different departments, and we landed on we're going to try and go all electric, total site energy use all electric, and then lay on the solar systems as they become cost effective for us as a school district. Next slide. And so here's our district strategy in a quick snapshot. All new schools or new building construction will be ZNE ready. That'll be an all-electric site that'll have solar-ready roofs for when that cost comes down and our rates go up. Modernization will be a nice two-step process over the next couple bond cycles in which we're going to touch a site for the first time, and we're going to really focus on the envelope and lighting, and then go back and do the heating systems. And then, like I said, renewables in due time. We are a municipal electricity customer. We've been beneficiaries of very low electricity rates for a very long time. Now they're actually starting to come up enough to where the solar is making sense. And as everybody I'm sure knows on this call, solar costs have come down dramatically over the last couple of years. Next slide. And here's our stairway to ZNE. I touched on it really quickly in the last slide, but we're really focusing on implementing this process in a thoughtful, thorough way in which all the departments, specifically our maintenance department, really are on board with. And so we start down here, and this is our shared savings. This is our behavioral engagement work where we go to school sites, teach teachers how to use their sites, do data analysis, little mini capital projects, and really focus on the low-hanging fruit. Then we're going to focus on the passive, really insulating our buildings, double pane windows, do that switch to LED district-wide. And then for heating, we're going to slowly implement over the next 2 decades a switch from boilers to heat pumps, and then renewables and EV charging, battery storage will all be a part of that future. Next slide. And we're going to do this process through our standards and through our normal bond modernization process, and that's, I think, what we as a district are trying to convey to other K-12s across the nation, that you can do this process. ZNE is possible. You just have to have the conversations and start those conversations with everybody in the district and really work them into your standard practices, whether that be your standard bond modernization or your standard facility project, just general maintenance. It is possible. You just have to have a thoughtful plan in which you as your school district and your departments are going to go about it. Next slide, please. And so as part of our recent bond process, we just had one pass in fall. We are going to have ZNE modeling reports done for each one of the sites, and these are a couple pictures here. You can see, if you look closely, that each one of the engineering firms is going to lay out different technologies and how those cost impacts will be on utilities, as well as how much they're going to lower our EUI. We have a target EUI for all of our sites of 20, and that's what we're really handing over to the architects with some guidance through an OPR and say, here you go, this is the goal, show us the way you're going to do it. The other big benefit from these reports is we're going to be able to take these recommendations, whether it be electric domestic hot water heater or a zone level heat pump, and work with our cost estimators to see how that will work within the budget of the bond process. Next slide. And so our first ZNE retrofit opportunity will be Garfield Elementary School. This is one of the PG&E Prop 39 ZNE pilots. The site has rooftop units, just standard furnace units with air conditioning. We're going to be switching over to a VRF or a VRV system and really layering on the solar panels here. We expect each one of these different roofs to be completely covered with solar to get us down close to a ZNE. Next slide. And then our new construction opportunity will be at Claire Lilienthal Elementary School. We're going to be replacing these bungalows right here you can see on the left-hand side with a new building construction. Again, that'll fall into the ZNE Ready category, in which we're not going to go ahead and layer on the solar. right away, but it will be constructed with a target EUI of 20. Next slide. But why stop there? Why stop at our buildings? Why not look bigger and beyond and really go after all our carbon emissions and greenhouse gas emissions? So facility energy use, which is primarily the natural gas for our boilers and domestic hot water heaters, makes up about 70% of our total greenhouse gas emissions. The other third of that comes from vehicle fuels, and we have a small vehicle fleet. Next slide. In which we're working with the different departments to really implement electric vehicles, and those are coming down in great costs. We have a great little video of us getting stuck on an electric van going up one of San Francisco's hills. Technology is getting there. It's improved. They actually did an over-air update, which allowed us to zip up the hill the next day. But we're really looking to implement this again over this long-term period of the next 2 decades. Next slide. And we're going to be working with our local bus transportation to implement renewable diesel fuels, and that will be a part of our next bid contract with them. Next slide. And so here's our carbon neutrality or zero carbon policy. Effective immediately, we're going to design buildings to be ZNE that are going to be new. No new gas heating systems will be installed. This will be major overhauls during our bond modernization process. And we're actually working with our local utility commission to retrofit opportunities when boilers do fail outside of that cycle to install VRF or heat pump units. By 2020, we're going to focus on only buying new electric vehicles. All our diesel buses will be burning or using renewable diesel. And we have an office goal of reducing our natural gas and water use by 30%. 2030, district-wide, all vehicles will be emissions-free, and upping that percentage to 50 for natural gas reduction and water usage. And then by 2040, the big goal is to no longer use fossil fuels for heating or transportation throughout the district. Next slide. And that's a quick wrap-up of what we're doing here. Hopefully this is kind of inspiring for other school districts, and be happy to answer questions as they come in. My contact information will be on the last slide as well. Thank you.
Hi, this is Jason Robbins. I'm currently with McDonald's, but I've only been so for the past 6 to 7 months. Prior to that, I was with Walgreens for 12 years, where I got to start my career, and I got to end it with one of the most personally rewarding projects that I've my career, which was the Walgreens Net Zero building in Evanston. Next slide, please. Next slide. So the vision for the project was written by our corporate person, but basically it was to create a showcase for innovative and sustainable high-performance retail design. The rest of it's all fluff, but some of it does have some meaning. But it was basically build the best building that we could with the most up-to-date designs and most energy-efficient ideas that we could come up with back in 2012. Next slide. This is what the building ended up looking like. The elevation is facing west, so we have quite a bit of west-facing glass, which was not the best energy decision from a modeling perspective, but gave the look and feel that we were looking for from a building to really represent what we were trying to do. Next transition. There's some site features here that if we peel back what the finished facade looks like, you can see the amount of steel and structure going on in the interior inside of that building to support the unique kind of visual aspects that we were going for architecturally, as well as you can see the turbines there, and we did native and adaptive plant species. In the parking lot, we did rainwater collection, which you can kind of see the cisterns there in the picture. Next slide. Our project goals were to be the first net zero energy retail store in the U.S. Retail stores are pretty challenging for net zero because they have occupied high percentages of the year. This store is occupied almost 5,500 hours a year, which is a lot more than what a typical office building or school or some other building types. So that's a huge challenge in terms of operating load. That check mark is in yellow because we have not yet had a 12-month period of time in which we were exactly net zero or more. But we also wanted the project to be LEED Platinum, to be a Better Building Showcase project, Green Shield Platinum, which is an EPA award for innovative use of refrigerants or reduced refrigerant use, Energy Star, and we needed to open before Thanksgiving in 2013, which was just 14 months total for design and construction, which was a mistake in retrospect. Next slide. So our energy reduction strategies are going to mimic pretty much what you've heard throughout all the other presentations. We needed an ultra highly efficient mechanical system and also, as well as refrigeration. We have a walk-in cooler and freezer that does both merchandising and storage of product, and on this location it was nearly half the length of the building. We used 8 geothermal wells, each 550 feet deep, and we also used all LED lighting on this project, even though it was not quite kind of ready to go full stream in terms of every single fixture. We did go ahead and make that decision back then to go all LED. In addition to LED, we looked at doing some different things that you can do with LED versus fluorescent, and that's directionalizing the lighting pattern. So really going to like the next level of lighting design. With LEDs, you can really play with where the light goes, and we were able to get our lighting level down to 0.7 watts per square foot in a retail space, and you'll see a couple pictures that show really how bright the space is even with that low level of wattage. We did daylight harvesting, with the first Walgreens ever to have operable windows that operate on actuators. We had 5 separate dimming zones. Again, that was probably a little bit too complex. The dimming system we had some disco parties with some strobing lights. So if anybody's ever played around with dimming systems, they can be a little tricky. We did a revolving door, which is not typical for a Walgreens, but did save quite a bit of energy in those winter months for infiltration. And we did a full-blown building automation system with every single circuit monitored for energy usage so that we could understand how the building was actually performing versus design. Next slide. So my one thing that I could go back to after doing this project was that try to keep everything very, very simple, but some things can't be made too simple. So keep everything as simple as possible, but not simpler. Next slide. And that brings me to what our mechanical system looked like. So it does not look very simple, but when you look at that, this is the total schematic of everything that gets hot or cold in the building gets run through this one machine. Next slide. There's a picture of that up on our mechanical mezzanine, what that looks like in real person, and that space is publicly tourable. Next slide. So this is the schematic of that system, so it doesn't look as scary like this, but basically all of our hot water, domestic hot water, heating, chilled water going down to our freezers and coolers with direct CO2, and all of our geothermal loops are tied in through this one transcritical CO2 rack. Next slide. So the green highlighted pipes here are all the geothermal connections. The blue are chilled water. The red pipes are hot water and domestic hot water. And that's how they all integrate back into this one kind of thermal management system for the building. So all the heating, cooling, and refrigeration loads are done together. Next slide. The building wasn't just about trying to achieve net zero. We really wanted to do everything possible to have kind of an environmental awareness showcase. So the existing building that was demolished, we recycled 84% of it. We used adaptive plant species, all low flow water fixtures. We collected all of our stormwater on site into the cisterns and didn't discharge any into the city's stormwater system. which is a pretty big issue in the area of Chicago because as the cities have grown, the stormwater systems have not. So we tend to overwhelm city stormwater systems in the area. Low VOC fixtures and finishes were used, as well as we put in electric vehicle charging stations for people with those Teslas that are so cool to look at. They have a place to charge. And then we also did educational signage throughout the site, including outside, inside, basically anywhere a customer can go, there was signage. And that ended up being more important than we even thought because it was one of the main ways that we interacted with our customers. Next slide. So the results, you can see at 100% what our typical Chicago average EUI would look like. We did our first geothermal store in Oak Park, which is also a Chicago suburb, and we achieved roughly a 40% energy reduction just by doing geothermal. The detailed energy model on the right of where we hope to be, which was a 60 to 70% reduction, and where the first 12 months landed in, which was just a little bit better than the geothermal store. Next slide. This is the first 12 months of operation. The blue is our actual net energy usage, and the green is the predicted. So you can see that we weren't too far off of where we wanted to be. Generally, the curves kind of look like each other. It just didn't do exactly what we thought, and we continue to learn why. Next slide. So our typical EUI in Chicago is 105. We are predicted through all of our modeling based on what we knew when we were designing it was to be an EUI of -5. The first year of operation we had an EUI of 20, and the last 12 months or 2016 we had an EUI of 15. So we're still a bit above net zero, but one of the things that did not get accounted for was those electric vehicle charging stations. We didn't predict that they would be used as much as they had been, but we have a Nissan dealership just a few doors down, and they found out our charging stations are free. So they got used quite a bit more than we expected. If you remove the electric vehicle charging stations from the building usage, the EUI drops to about 5. So there's a couple things that are still going differently than expected in the building that are being worked on to address, and we hope that within the next 18 months we'll have 12 months of net zero performance. Next slide, please. So our overall lessons learned is try not to rush this. Commission is very important, and it needs to happen before you occupy. Engage your contractors as early as you can, and kind of try to expect the unexpected. But this was a fantastic project to work on and was really cool to be a part of it. Next slide. So this is a picture of the inside of the building. You can see that glass on the back wall where that's the mechanical mezzanine, where that's publicly tourable space. You can go up and see what's going on. And you can also see the clear story windows between each elevation. Those are the operable windows, so those open and close as controlled by the building automation system. Next slide. All right, sorry, that's all, and if you have any questions, please feel free to email me, and there's going to be a link on the additional resources page here to a time-lapse video of the demolition and construction of the project. Thank you.
All right. Thank you, everyone. All right, let's go ahead and get some questions answered. I understand we're running out of time, but I wanted to still, for those that can hold on for a little bit, I want to ask some questions. Riley, over to you first. Has there been any cases where ZNE was achieved in a building without the use of solar PV?
No. That's always a tough question. There are very low EUI operating buildings. The one off the top of my head is the Bullet, which I think has an EUI of like 10 or 12. It depends on the building type too. Like there's some passive houses that are probably also operating at a very low EUI. I hope that answers your question.
Does 10% incremental cost refer to upfront costs only, or is that net of energy costs?
That's net of rebates and other incentives that are taken into the upfront cost.
Thank you. Some questions for me are, can any of these ideas about zero energy resilience, health supporting schools be floated among other students, teachers, and parents to hold decision makers to a higher ideals of construction? That's exactly what we are trying to approach our Zero Energy Schools Accelerator frame with. We want to arm the districts and the states that we are working with on how to best, engage with their stakeholders. How do you add the zero energy language into your curriculum, but also into your engineering and architectural design as early as possible? But definitely, how do we engage your community as well as parts of the Accelerator program? Will Better Buildings have a webinar for residential zero energy homes? At this point, unfortunately, I do not know, but if you were to go to our zero energy homes website, I'm sure you'll be able to receive as much information as possible and try to sign on to their EERE's blogs to get more information. Next question for Nate. What is the biggest challenge to getting carbon neutral policy of your district?
So we went to our board, and the board said, make it stronger. So they're on board. The big concerns we have, as many people have brought up, is costs. There are incremental costs of doing this, so we're really using our next bond process to see what those costs are going to be like. And then the other thing that we're very, very cognizant of is the maintenance issues that come with this. School districts are chronically understaffed in their maintenance departments, and so that's why we really wanted to focus on those passive technologies first. Really tightening up our building allows us to run our systems less, allows us to design smaller systems, which makes it easier on our maintenance staff to maintain. So cost and maintenance, big concerns.
Okay. The next question is, in San Francisco Unified School Districts, are they funding solar through PPAs or purchasing solar outright? What does the electric rate and cost for solar PV have to become so installation of solar PV is cost effective?
So we have a rate this year of 7.5 cents and roughly, and we have arrangements with our local municipal PUC where they install solar on our sites, but that doesn't necessarily benefit our utility bills whatsoever. We purchased one through a bond modernization outright and have yet to get that online. But as those rates increase, we're starting to see, we're expected to go up to around 13 cents per kilowatt hour. And at those rates in California with the ITC, other firms are offering some prepaid PPAs below the 10-cent mark. So we are interested in the PPA, also kind of exploring the outright purchase model. Yet to be determined for us, but definitely a very important piece of the puzzle.
Okay, thank you. Question for Jason. What features in this store is Walgreens now consistently including in new stores? All LED, revolving door, or any others?
There's a few features. All LED was one of them. Now all new stores for Walgreens design are all LED inside and out. So for the site and all the buildings. There's a couple of features that we didn't really talk about, but low flow fixtures for water. There is a daylight redirecting film that we used for our lighting strategy. That's being used anytime where we have a lighting issue like that, as well as natural ventilation has been done at a few more locations, but not at all. So there was a few, but the LED and some of the daylighting strategies were the main ones.
How much was the premium in cost for this Walgreens versus a regular store, and how many years until the added cost is paid for out of the energy savings?
That one's a little tougher to break down, but the premium for all of the items that contributed to net zero, like the mechanical system, solar, the wind turbines, and any additional installation, was about $1 million versus a $3 million typical construction cost, so about a 33% increase. although this building did cost more than that to build, there were a lot of elements that had nothing to do with those aspects of the design. For instance, we had to clean up several underground storage tanks that we found hidden on the site that cost a lot of money, and some of the structure that was more architectural than anything. So it was about $1 million in the energy saving technologies.
I'll add one more question to you. What's McDonald's doing towards net zero energy?
McDonald's is currently investigating net zero. One of the things that's quite different from a standard retail store is the full commercial kitchen, which is a very large and has a very large energy density, and there needs to be some additional developments in some of that technology in the kitchen before we can get the EUI in the ballpark where net zero can be attempted. So we're working on developing those technologies for the kitchen side to make net zero possible for a restaurant like McDonald's.
Thank you so much. I understand there were a lot more questions than that. I apologize as we are running out of time. I need to end the question and answer session right now, but please feel free. We will have all our email addresses on the following slide, so please feel free to ask us those questions. So next slide. Hopefully you will join us for the next Better Buildings webinar series. It's on wastewater matters, and it will take place Tuesday, April 4th, again from 3 to 4 p.m. Eastern Time. Next slide. And I guess more importantly, we would like to invite all of you to join us to the Better Buildings Summit taking place in Washington, D.C., May 15th to the 17th. This is a national meeting where leading organizations across key sectors showcase solutions to cut energy intensity in their buildings. It is designed for partners and stakeholders to exchange best practices and highlight demonstrated market solutions with an equal emphasis on discussing future opportunities for greater energy efficiency in American homes and buildings. So please take a look at the website below and sign up and join us for this accelerator. For this summit. Next slide. In front of you, you'll see all our information with email addresses. Please, again, feel free to contact each one of us if you have additional questions or any comments. With that, I'd like to thank our panelists very much. Thank you very much for taking the time to be with us today. And if you'd like to learn more about the Better Buildings Challenge or Alliance, please check out our website or feel free to contact any colleague or Holly Carr, that her email is also listed on here, directly on the email shown. I encourage you to follow the Better Buildings Initiative on Twitter as for all our latest webinars or activities, and you will receive an email notice when the archive of this session is available online. Thank you, everyone, and have a wonderful rest of your day.